I'm Kate Simmons-Tillotson, Director of Strategic Partnerships at Masthead, Maine. We are so excited to welcome back to Like a Boss, Dr. Ed Liu, President and CEO of the Jackson Laboratory. Dr. Liu first sat down with Lisa for Like a Boss in February of 2018. If you want to hop back and take a look at that interview, and we are thrilled to have him back to discuss the work that Jax is doing now. We are so appreciative of our presenting sponsors, Bernstein Schur and Hub International, as well as our Like a Boss Live series sponsors, Harvard Pilgrim Healthcare, JP Morgan Chase, Vistage, and Coffee by Design. And excitingly for Coffee by Design, they're now doing curbside pickup at their Congress Street, India Street, Diamond Street, and Freeport locations. So lots of places to get your coffee fix. I'd like to extend a very big thank you to Like a Boss Now sponsor Hub International. Hub is the 5th largest insurance broker in the world, and they have strong local roots in the Maine business community. And here with us today is George Watts, Senior Vice President of Employee Benefits, to say a few words. George.
Thanks, Kate, and good afternoon, everybody. I'm excited to welcome all of you today. I'm George Watts, and I'm the Employee Benefits Practice Leader in Maine for Hub International. You've gotten to know my colleague Peter Fendler pretty well over the last couple of weeks, and we thought we'd mix it up a bit to show you there's a little more to Hub than just Peter. So good to see everybody. I think we're all anxious to hear what Dr. Liu has to say today about the groundbreaking work Jackson Labs is doing as it relates to COVID-19. I'm also looking forward to hearing about how his leadership is guiding his team and the community through this unusual time. In employee benefits, we work with human resources teams to help them establish strong leadership and company culture, because we know that's groundwork for success on so many levels. And if it was important before, it's critical now. I think we'll all learn quite a bit from Dr. Liu this afternoon. And with that, back to you, Kate.
Thank you, George. And it's so great to see folks in the chat saying hello, seeing who's here. So if you get a chance, say hello and make sure that your setting for chat is set to everybody so we can all see your wave. Now I'd like to introduce one of our friends from our presenting sponsor, Bernstein Schur, shareholder Kat Joyce. Kat.
Thanks so much, Kate, and good afternoon, everyone. My name is Kat Joyce. I'm a shareholder at Bernstein Schur, and I am our Energy and Environmental Practice Group Leader. Bernstein Schur is so honored to support these conversations and is grateful to the Portland Press Herald and Lisa for finding creative ways to convene our business community in such challenging times. You were certainly on to something when you decided well before this crisis to bring people together to learn with and from each other. Little did you know just how critically important such sharing and cooperation would become. So from my colleagues at Bernstein Schur, thank you for your leadership. And I so look forward to learning what Dr. Liu has to share with us today.
Thank you, Kat. It's exciting to see folks from Bigelow Labs and Brooke from Waterville, just down the road from me in Limerick. So many great folks with us today, and we're excited to hear from you. So please keep weighing in on questions and saying hello. And now with that, I'd like to introduce the publisher and CEO of Masthead, Maine, Lisa DeSisto, and the president and CEO of the Jackson Laboratory, Dr. Edison Liu. Take it away.
Thank you, Kate, and thank you, Kat and George. We really appreciate your support of this series. And welcome back, Dr. Liu from sunny MDI.
Thank you very much. It's a pleasure to be back.
We so appreciate your time because we know what a premium it must be at right now as the Jackson Labs work to help us through this crisis, but also continue the important work that you're doing there. So let's start with your experience actually before COVID-19 responding to a pandemic, because you were in Singapore and worked on the efforts there to contain SARS. So tell us about that experience.
Well, I was recruited to start the nation's genome program, and in 2001 and 2003, the SARS crisis. This is the precursor, so to speak, of the COVID-19 pandemic. They're the same viral family called coronaviruses, and it showed itself also in China. This time, instead of Wuhan, it was in Guangzhou. And when the first cases arrived in the shores of Singapore, we jumped into action, and I was fundamentally the chief scientist that helped with the team, some of whom are actually with me right now in Jackson Labs, to sequence the virus, to develop the first diagnostic, which was subsequently taken up by Roche Diagnostics, and used that information to guide the country into the resolution of the problem. But in the midst of that, we learned a heck of a lot, mainly on how to use testing, how to organize a nation, how to mobilize all the forces that are necessary, including contact tracing, isolation of infected individuals. And ultimately, we cured the problem. So by the end of May, from the time it started, which was in around December or so, the SARS was in effect eliminated from Singapore and Southeast Asia.
And so in terms of eliminating COVID-19, the cat's way out of the bag on that, correct?
Yes, unfortunately.
Yeah.
For SARS and for MERS and for some elements of Zika and Ebola, the genie was put back into the bottle, so to speak, and that really required a tremendous amount of effort and infrastructure to have that take place. COVID-19 is the cat is out of the bag, and it's unfortunate, but I think we can deal with it.
So I would love your assessment of how you think Maine is responding to COVID-19, and maybe what advantages or disadvantages we have over other states.
Well, all pandemics require several conditions. Number one, contact of human beings with human beings in a frequent and crowded manner. And in fact, Maine has an advantage because we are to a certain degree remote, and we're not dense in that, and the numbers reflect that. You can see that compared to Massachusetts, certainly compared to New York or California, even our surrounding states of Vermont and New Hampshire, we're doing actually pretty well. Now, it doesn't mean that we're not affected. There are considerable pockets. They tend to be in nursing homes, as right. Perhaps you've seen, you've heard from Dr. Nirav Shah. And also, we are a popular destination for people with second homes here, as well as for tourists. So the movement of individuals will be a constant source of infectivity.
And so as a scientist, what's your assessment of the social distancing, staying at home, wearing masks? Do you believe that it's working?
Oh, absolutely. And the data really shows it. In every single case where you looked at when social distancing took place and when the plateau or the flattening of the curve, it's pretty consistent. It's consistent in the as long as the social distancing policies have been enforced or actually embraced by the public at a significant degree. Within 2 to 3.5 weeks, there's a flattening of that infectivity curve. The challenge is, of course, is not just flattening it out, but actually reducing it so that the incidence rates go down to zero, which is what the Chinese have done, and to a great extent, the Koreans have done as well. And so social distancing really works. It worked in the past for virtually every pandemic, and it's working again. The challenge is how long can you keep it up? The right. challenge is its effect on the economy. And it's that balancing act that is usually the most difficult for any society or any governmental structure to handle.
Well, there's been a lot of talk about that key to reopening the economy is directly connected to testing. So do you want to talk about JAX's role in testing?
Yeah, the testing was the critical piece that we did at the SARS crisis. When this first happened, the head of the medical system for the country and I got together and decided that the most critical thing that we could do in the first instance is to develop the test. And lucky for us today, compared to 2003, the technologies that we have at hand, and it's all genomic technologies that the Jackson Labs is really one of the leaders in. And it has to do with sequencing nucleic acid, sequencing, in this case, RNA instead of DNA. And then once you know the sequence, then you can actually construct a very sensitive polymerase chain reaction test to detect even small amounts of the virus. When the epidemic first started in China, within less than a month, the virus was identified to the nucleotide, actually to this exact genetic signature. With that, the tests were being promulgated throughout the world, including, as you know, in the first instance in the US CDC. Since then, the might of the American biomedical, not only research, but industrial community really ramped up to develop testing in a large scale. That's still a challenge, but a lot of that challenge is not necessarily do you have the ability to test, it's actually the accession of the samples.
Mm-hmm.
You can imagine the situation where you have a massive distribution problem. You have to distribute these swabs to every single hospital, every single practice, and will there be enough of those in the scale that we're talking about, which is unprecedented, at least in my lifetime.
Mm-hmm. And you have developed a test at JAX, correct?
Yes, and here again, what we did was knowing the cycle that is necessary in order to control a pandemic, we decided to stand up the diagnostic test, the polymerase chain reaction diagnostic test, in very early March. And because this is the technology we're very familiar with, and we have many connections with people who've actually scaled up the production of the
mm-hmm.
reagents, we were able to stand up the test in scale within a very short period of time. So right now we're doing about 550 tests a day. That will be expanded to 1,000 and 3,000 within the next 10 days. And our ultimate goal is 20,000 a day by somewhere in mid-July.
Wow. Now, are you distributing any of your tests in Maine right now?
Yes, we're doing the test now. I think it's really worthwhile to really define what a test is. Okay?
Yes, very good.
Because there is an antibody test and then there is a viral test. Okay, and what I'm talking about is the viral test. And what it is we take a sample, break up the virus, take the nucleic acids or the RNA, which is the genetic guts of the virus, and then test its presence. The antibody test is actually a test of whether or not you have antibodies against the virus. So you have to have been infected by the virus to produce that antibody. So what's the difference between the two? The viral test will tell me as a physician whether or not you not only are infected, but whether you're shedding the virus as well. In other words, by shedding the virus means that you have a likelihood of spreading the virus. The antibody test simply tells me whether or not you have been infected by the virus. And to a certain degree, though this is actually the biggest problem we have right now. Normally, if you have generated antibodies, you would have an immunity against that virus. Just like you would have immunity against measles or immunity against a strain of influenza. But right now, because of the strange behavior of this virus, we're not sure if that's going to be the case. Just because you're antibody positive doesn't mean that you will be immune. So we can't use that for clinical assessment of infectivity. So it is really the viral test that we're doing. We do the viral testing, and we'll be doing it up to 20,000 a day, but the people who are actually sampling the patients, that is taking a little swab or getting the saliva, they are your family physician, the nurse practitioner. Now more and more pharmacies are actually collecting those get then shipped to groups like ours, and then we do the analysis. So that's the life cycle of doing a test.
And what about widespread testing, though, finding people who are asymptomatic as opposed to just testing people right now who are showing symptoms? What's the outlook for that?
Well, you know, when we were doing the SARS work, there was no need to test asymptomatics because of the nature of the virus. People don't shed the virus until, that is the SARS virus, until they have symptoms. So you have a symptom, let's test you. Now, because you want to know whether it is SARS or whether it's influenza or whether it's rhinovirus, which is a common cold. You know, those you don't worry so much about because there are things you can do, or it's a minor. In this case, the SARS-CoV-2, which is the virus that is causing our problem right now, it's a peculiar one because people are asymptomatic before that is, they're pre-symptomatic. In the pre-symptomatic phase, before they have symptoms, they're already shedding the virus for days. That becomes a significant problem. And then what we have been finding is that there's a small number of people, but not so small as to be insignificant, unfortunately, who are completely asymptomatic and continue to shed the virus for days to weeks. And there's been documented cases of individuals who are asymptomatic who have infected people who've been in close contact with them as well. We're learning continuously about the biology of this virus. And one of the challenges is that the asymptomatic shedders could either be spreaders or completely non-spreaders. And right now we don't have a test that will separate out those two. So what does it mean? It means that we really, first of all, anybody who's symptomatic will have to be tested, and the testing will allow us to put those individuals in quarantine so that they won't infect other people. And that's really the key. More and more, there are ways to screen asymptomatic individuals, particularly at high risk for being infected. For example, healthcare workers working in emergency rooms, first responders who are driving ambulances, and workers in nursing homes. Even if they're not symptomatic, they should be tested simply because of the high risk of being infected by the virus.
Right. So let's switch and talk a little bit about a vaccine. So what's your outlook for a vaccine?
Well, first of all, there's about 4 to 5 vaccine candidates right now that are very promising in the preclinical world. You may have heard of one that is called Moderna. It's an RNA vaccine that in the very earliest phases, in only 8 individuals, they actually generated antibodies. Those individuals generated antibodies to the vaccine itself, and the antibodies were what we call neutralizing. That is, that at least in artificial systems, it will neutralize the virus. That's a really good sign. So I'm very sanguine to that. Now, the challenge is, just because you see a response in a test tube does not mean that it's going to work or it's going to be safe, because there is a rare circumstance called antibody-dependent enhancement. It's a big word, a bunch of words, but what it means is, paradoxically, being vaccinated makes you actually worse when you get infected by the virus. So, and you will never know that until you actually take it into clinical trials. And in clinical trials, you have to test uninfected individuals and look at the rate of infection. You want to make sure that it is protective. And that means the trials are tens to even up to 100,000 people in order to see the efficacy. So I think we are going to have some kind of antiviral therapy first before we will have really a vaccine. And the earliest that we will have a vaccine is probably the first quarter of 2021.
So the therapies would be to treat people who have COVID, and the vaccine next step would be to help prevent it, correct?
Exactly.
Yeah.
And
so,
we have that armamentarium for the influenza, for example.
Right, getting a flu shot every year. What about the, what's necessary though? How many people would need to be vaccinated worldwide?
Well, it depends on your intentions. You know, I mean, the intention to eliminate polio and smallpox, which, by the way, have been with us for, if not hundreds of years, thousands of years, smallpox, for example, it was never eliminated, even though there was epidemics every few years, okay? It wasn't until mass vaccination on a worldwide basis that we were able to eliminate completely smallpox from the face of this earth. I mean, it was just the most astounding medical event in the history of mankind, okay? That's one way to go about doing it. But the other is like what we do for the influenza. We take, for many reasons, to completely eliminate influenza is nigh impossible, if not very, very hard to do. But what we can do is keep one step ahead of the virus and attenuate the dramatic symptoms by giving people the vaccines. And so in both circumstances, I think the vaccination has two purposes. Number one is really to protect you from the ravages of the disorder. It doesn't mean that you'll be free of it, but at least maybe not as severe. And then the second, which requires a lot more vaccination and a lot better vaccines, is if you want to eliminate it from the face of the earth, which would require a lot more than I think right now we're capable of doing.
Right. So let's talk about the Jax mice. So what role will they play in the development of all of these?
Well, for example, you know, this is a new bug and you don't really know much about it. So you have to experiment and you have to learn. Right now, the only way you can learn in a whole organism is in human populations. And there's no way anybody, experimenter will want to actually take the virus and infect a healthy person. It doesn't make sense. It's not ethical. Okay, so what we have to do is have a model system, a system that has enough resemblance to the human condition that when we do the tests and do the therapies, that we have some confidence that what we see could be brought back into a clinical mode. And right now, for many reasons, the only real animals that can be used are monkeys. They're our closest relative. And the reason for that is the virus, when it infects you, it has to bind a protein on the surface of your lung cells, let's just say, okay? In order for it to go into the cell, replicate, and then cause a chain reaction of infection. That protein is unique for the humans. The mouse version of it doesn't work for the SARS-CoV-2, the COVID-19 virus. So in 2007, Stan Perlman in University of Iowa, working specifically on SARS and MERS, which are coronaviruses, created this mouse where he put in the human protein, is called the ACE2 protein. And lo and behold, that now engineered mouse can actually take up those human pathogens and become a model, a surrogate, an avatar of humanity, so that we could test vaccines and test antivirals. Well, we just found, we knew that this was the case. We expanded. We actually got sperm that was in deep freeze. We did massive in vitro fertilization and developed an entire colony of these mice. And just very recently, the National Institutes of Health, working in conjunction with us, showed that this is a perfect model of a really fantastic model for the COVID-19 virus infection. So now you can test many drugs, many drug combinations, and have a much better idea of which combinations, which drugs really will work before you even apply it in human beings.
So you're taking these engineered mice that now have the human protein, and people are already requesting them, right? I mean, are you shipping the mice to labs around the world?
We're just beginning at this point, because it took us from February, March, April, May. It took us about 3.5–4 months to get in this replicative cycle, in reproductive cycle, enough mice so that we can supply the research needs. So we've already had requests from over 200 laboratories for over 7,000 of these mice, and it's only going to grow. This will accelerate by many fold the speed and the comprehensiveness of getting at a treatment for the virus. There
can't be many other laboratories worldwide that actually have the capability to produce these mice, are there?
Well, you know, to actually create the mice, many people can create mice like this. In fact, we are creating a whole new series of mice that are even more nuanced than the one that was created in 2007. They're really very important nuances, which underscores the complexity of the infective cycle of this virus. But it's really virtually no other place has the capacity to scale up the production in such a way that we can supply the rest of the world a solution to the COVID-19 pandemic.
It's just so remarkable that we have you here in Maine, and we're so thankful for that. The work that you do that can help around the world is remarkable.
And we do it from Maine. Isn't that great?
And we do love that. We're very proud of it. So I wanted to get your perspective on how to balance public health safety and the reopening of the economy. It's really, creating a lot of polarization in our state, a lot of varied opinions on it. What's your opinion on how to do it right?
Yeah, I mean, whenever you have a serious situation like this, where there are no clear answers, there's a natural polarization that happens. My view here is, first of all, what is the polar views? One is, let's shut the state down until we're clear of the disease. The other is, you're killing us because there's no economy. And the truth of the matter is, both are correct, as far as I'm concerned. Every pandemic has this balance that has taken place, from the plague to the 1918 influenza to what we have now. The key is also to understand that there's no perfect solution. And the other issue here is we can't go back to pre-pandemic conditions. That would be, let's put it this way, not quite, but committing suicide. We have to adjust. So what I mean by that is that there is a path forward But that path forward requires us to thread the needle on a constant basis. The path forward requires that we actually can see what's going on so that we can adjust as quickly as possible to changing circumstances. So what are the components for that? We have to be able to test and test in a massive scale. We're beginning to mount that capability at this point. But the more we can see, it's almost like trying to fight a submarine warfare without any radar whatsoever. You can't do it. You have to be able to see your perimeter and where your enemy is. The second thing is the willingness to actually isolate people who are infectious so that we limit the transmission as we wait for the vaccine to come. And almost everything we're doing now is mitigating things until a vaccine is really available. But the third thing is that with social distancing and with a variety of approaches, I think we can slowly, but consistently open up the economy and open it up in different sectors based on fundamental risk, as long as we can isolate individuals who are at high risk for mortality. For example, the elderly, individuals with intercurrent illnesses and the such. This will require, it's not rocket science, let me put it that way, but it requires several things that I hope we can mount, especially in a special place like Maine. Some consensus so that we can work together, the willingness to experiment, and everything that we do in every community is an experiment as to what will work for that community. And then the last thing is we've got to be willing to look at the data in a hard-nosed manner. And that really requires testing in a very reasonable and more dramatic scale than we have right now.
So what's your advice to the tourism industry?
That's a tough one. My son is actually in the hospitality industry, and I feel his pain. It's I think the unfortunate truth is we're not going to get it back to pre-COVID days, not in the short order. My hope is that we can work out a pathway so that there's a lifeline to the industry, and that we can keep things going until the vaccine comes, or when the virus may become more attenuated going forward. So what does that mean? It may mean, by the way, I'm not recommending this, but I'm telling you that these are some of the scenarios, and these are some of the comments that people that I've been party to in the conversation, that the workers, the restaurant workers and the hotel workers are actually tested just as much as the nursing home workers are, because they are the front for interactions, right? That you do social distancing within the restaurants. And that means less business, but this still means business. Right. That we put masks on all wait staff and gloves, not so much, unfortunately, to protect them, because these masks aren't that great for that, but to give assurance that that the guests will be will feel a little more comfortable coming in. And the other aspect is, you know, we've been into stores that says no shoes, no shirt, no
service.
Okay, yeah. No mat. If you have a retail store, no mask, no service.
Right.
Unfortunately, we have to do a few things like that to go forward. As long as we have those and the ability to test, so that if we see an uptick in infections, we have to then slow down the process, or else you'll be running like a wildfire going forward.
Right. I love this move where Portland is closing down streets in the old port to offer outdoor dining, and I think Bar Harbor's considering something similar as well.
Yes, I think it's really wise. Now, the big reason for that is that for influenza, for COVID-19, actually having good air circulation reduces the risk of continuous exposure to live virus in the air.
Mm-hmm. Well, and one of my favorite things to come out of this is curbside cocktails. So I don't know who thought of that and got it approved so quickly, but it's lovely that you can pick up some of these great cocktails at our restaurants to go. So more creative thinking to help the economy.
Yeah, I'll tell you one more thing that is also, again, we need to experiment, is actually to have sufficient testing for any tourist who is symptomatic.
Mm-hmm.
Okay, I mean, now, will that make a difference? We don't know. You see, part of the problem is that we don't know a lot about what will work in these circumstances, because the last pandemic we really had was in 1918.
Yeah.
It's a long time ago.
It is a lot. Yep. Yeah. So with the development of COVID testing, have you been able to keep the other important work at JAX on track? And what's the status of at your facilities and your staffing?
So, by the way, this underscores one very important point, and that is you got to get ahead of the curve, or else the curve will swallow you up. Mm-hmm. And maybe we can, if we have time, we can come back to why this is so important. But a lot because of the quality of my colleagues. Some of it is because of my experience in the SARS. We really jumped on this very early in the game and started to provide protective equipment for our colleagues, social distancing, and taking and thinning our workspace by having remote work. And you being in the newsroom know exactly what I mean by having people just work from home. But even so, as you know, we have essential workers who really have to keep our particularly our mice going in a safe and humane manner. So in total of we have 4 campuses in 3 states. Okay, and so we've of 2,400 employees, about 1,500 have had to spend time at the workplace. About a little more than 1,000 full-time in the workplace, and the remainder only part-time. And thus far, knock on wood, they've been doing relatively well. And and the social distancing, by the way, including social distancing in the workplace itself, really, I believe, has helped a lot.
So let's see, I start to pepper in some questions that we got from our attendees. And I also want to encourage folks, if you'd like to ask Dr. Liu a question, you can either raise your hand and Strawberry will welcome you live, or you could pop them into the Q&A and we'll start to see those in there and get those asked. So Jennifer Kirkland had a question. In this time of turmoil, what do you think we need to focus the most on with limited economic means? Testing, vaccination, or economic support?
Well, my view here is, first of all, the vaccination is going to be essential, but we don't have it. So, that's neither here nor there. And almost inevitable, the federal government will subsidize the vaccination. I can't imagine that they won't do anything like that. Okay, so I would say in this order of importance, all of them are important. In the first instance, is get the testing up and running. Yes, I'm all for economic support. But you know the saying, if you give a starving person a fish, you feed them for a day. If you give them a fishing rod, you feed them for life. It's a little bit of hyperbole, but you get the drift. Sure. By giving a bolus of economic support, you really keep people on life support, but only so long as you give them that amount of money. The testing is really the key for us to resolve the pandemic problem in its totality before a vaccine, before a antiviral treatment is made available.
Catherine Stratton has a great question. I believe every hardship also presents us with opportunities to examine practices, behaviors, and beliefs. We've experienced many changes in the workplace and society as a result of COVID-19. What do you see as the best and brightest learning, and what are the opportunities for change and improvement we should hold on to?
Well, I think this is a very, very astute question, but it can be answered in so many layers, Catherine. I mean, I wish we had another half hour to go through it, but let me just, as quickly as possible, hit the highlights and go down to the local. The biggest issue here is the learning is we have to be prepared with our science. In other words, science is and technology is really the salvation for us in solving the COVID-19. Everything I told you, every solution that I've given you has science, genomics, vaccines, chemistry in the therapy, and to mount those in such a way that we have a quick response is something that US is uniquely capable of doing. But unfortunately, we're not as coordinated as we really could be. So the lesson is science does work, but we just have to manage it a little better than we have before. The second aspect of this is that at least for Jackson Labs, I'm going to take it all the way down to the local level. First of all, we've shown how resilient we are. I'm so proud of my colleagues in terms of how they rally to each other's support, rally to keep continuity of our business plan, and really worked with me and the leadership in things like employee testing and really embracing the social distancing and use of personal protective equipment. But an important part of this is that we're already thinking about how we will change our work processes going forward, okay? There's going to be a lot more working from the home. And it's not just for viral safety, it's because it seems like we have lost no productivity whatsoever. And in fact, there are a few occasions, many occasions, where our colleagues say they're more efficient,
right?
Not having to commute, you know, from off island and back and forth and everything. So we're looking at different ways of managing and different ways of doing work.
A question from Todd Yankee. Can you address the apparent need for national standards rather than each state setting their own standards?
Well, let's put it this way. Again, it's a balancing act because of the following. I do agree that national standards or at least national coordination is better than no coordination, okay? At the same time, each state is so different. I mean, what works for New York and Manhattan, it's not going to work at MDI. I can almost promise you that. So some kind of local control or local solutions does two things. Number one, it's more flexible, it's more reactive to the local conditions. For example, you have to shut everything down in Manhattan, but do we have to shut everything down in Caribou? I mean, it's a different condition. But the second aspect of this also is that we don't know what the absolute best way is of doing things. So if we let different states explore different solutions, so long as they're medically based and they're rational, let's take a look at it. You know, what might work in Nevada or in Wyoming may just be the path that we want to follow in Maine.
A question is, will CRISPR become an important tool for COVID-19 research?
A very astute and technical question. CRISPR is a phenomenal new technology that is in the genetic genomic space. And what it is a way to precisely engineer changes in your genome in remarkable ways. Now, very recently, some scientists at MIT and other places, but have developed a diagnostic using the CRISPR recognition system that is now incorporated into a company that, that promises potentially a 1 to 2 hour test with absolute precision. And so consequently, we're very excited about that. But again, it's a matter of scaling and going forth. But in terms of treatment, that's not going to happen, certainly not in the immediate response phase. Mm-hmm. Not with CRISPR.
When do you think we will have reliable data on the actual percentage of people who become seriously ill from the virus? I've seen everything from 5% to a fraction of a percent.
Yeah, so this, let me just say, this is a surprisingly complex question, okay? Very, very surprising. And for these following reasons. Number one, at one point, there weren't enough tests to go around. So we had to, estimate who had COVID-19 in the midst of an influenza epidemic at the same time. So the denominator, the bottom part of a fraction, it was unclear. The second part of it is that even when testing was available, it was not widely used, and it was only used for the very sick people. Well, if you do that, then of course you will get a lot, what we call case fatality rate that is relatively high. But what we do know now is that that COVID, the SARS-CoV-2, the COVID-19 virus, is a very deadly virus, but is dependent on your characteristics. If you are a young individual, your case fatality is your chances of dying are lower. They're definitely not zero, but they're lower, much lower than if you're over 60, over 70, and over 80. If you're over 80 years of age, your possibility of dying is potentially 1 in 5 or 1 in 4. That's an extraordinary mortality rate. Okay, so that's why it's complicated. In Italy, they had a poor, not well-structured medical system. They have great doctors there. I know a number of them, but the medical system is not as organized. And then the second part, it's actually an elderly population that live actually with their families close together. Okay. You contrast that to Scandinavia, where people tend to live alone, and there's more remoteness that is there. And then you contrast that to Germany, versus where they still have a high rate of infection, but they have an excellent diagnostic system, and their case fatality rate is extraordinarily low, and nobody really knows why. But we do know that that COVID-19 is a serious disease. But we now know more and more that it's fractionated out to certain people who are at much higher risk for dying than others.
Strawberry, I think you indicated someone has their hand up for a question.
Yes, Susan Foxlin, if you want to go ahead and ask your question. You may have to unmute on your end. There you go.
Got it. Got it. Hello, Dr. Liu. Good to see you. As an architect, I understand that the workplace post-pandemic probably will be forever changed. we are really looking into, de-densifying the workstations and whatnot. But curious to know your insight on what the future large gatherings would look like, such as sports event or rock concert. Would that be gate, seats set further apart, or would that be a gate that would check everybody? What is your insight on that? Thank you.
My gosh. First of all, Susan Foxlin is actually the person who designed our Jack's Genomic Medicine facility in Connecticut. So a nod to Susan, who's now in California. This is beyond my pay grade. And to be honest with you, I really can't tell you how to build a stadium or an auditorium. The truth of the matter is, that's a aggregation of people, and it's not so much whether you're 6 feet apart, but more, do you share airspace with each other, to be frank with you. Now, the truth is, I suspect we're better off trying to kill this pandemic than we are to try to reconstruct massive design. Having said that, there will be other pandemics, and I do wonder whether or not some of your design expertise could be put to play about things like air handling. I don't think there's been a lot of attention paid to how air handling relative to pathogens. We know about air handling when it comes to how many clearances you have in a room. But what about airflow for the purposes of minimizing aerosol flows, which is really the infectious particles for the virus? Those are the type of things I think we need to pay attention to.
All right, I think we have time for a couple more. Can you talk about the false positives, false negatives in the testing of the virus and antibodies?
Right. So this is a real challenge because people use specific numbers that are true but incorrect. Okay, what I mean by that. And the false positive rates are going to be highly dependent on the incidence of the disease in a population. Let me give you an example. If you have 1 in 1,000 individuals who in a population that has disease, okay, 1 in 1,000. And these are real 1 person with a disease and 1,000 and in 199 without disease. Let's just say your test has a false positive rate of 0.1%. Okay, which, by the way, there is no test in the world that is perfect. Absolutely none. Think about it. 1.1% of 1,000 is 1, right? If you have 1 person who is true positive, 1 person who's false positive, then what is frequently said is, my God, you have a 50% false positive rate. Now, you know darn well that a test that will, on a technical level, give you a false positive rate of 0.1% is a pretty darn good test. But very frequently, people call the false positive rate is when they have a patient population that says 50% of the positives are wrong, okay? But if your prevalence is 100 real individuals, and you only have 1 that is wrong, that's not so bad. That's a number that you will definitely tolerate. So that's a long way to say that I would worry less about the false positive rate, in the sense that there will be errors, but in this case, those errors don't lead us down a therapeutic path that is draconian. I won't use this test to say I have to amputate a leg or not, okay? In those such circumstances, you better be darn sure that when you say it's a positive, it's a positive. But in this case, we can retest if we have to. In this case, we're going to keep you at home for a week, in the worst case scenario, or 2 weeks.
So a couple final questions, and this one's about your leadership at Jackson Labs. How has your leadership changed or been tested during this time?
That's a very, very good question. Certainly, it's been. Let me just say that leadership is really, I believe, it can be cut in many different ways. But one way you cut it is your what I would call immediate leadership. How do I deal with you as a peer, as a coworker, versus the long-term impact of your leadership. That is, have I been successful in building a culture that I want, one of cooperativity, one of efficiency, one that has a fantastic quick response. And in that context, I think that that the leadership, the hard wiring of the institution based on whatever leadership that I've been able to exert has been extraordinarily tested, and it's proven to be extraordinarily and fantastically resilient. Okay. Now, having said that, I can't claim that it is just me. I have some of the best people I've ever worked with in my life working at the Jackson Labs. They are truly the top of their game. They're committed to our mission, and they happen to like each other. I mean, you know, that's hard to find, okay?
Yeah, and it makes a huge difference.
Makes a huge difference. And so I think that's the thing that I'm most proud of, is the resilience that we've been able to build, and based on not only the process, but the culture as well.
Well, when we sat down in 2018, you talked about your staff being dedicated, understated, and committed to the mission. And I think that's what's really carrying you through.
I think so. I think so. I'm jokingly say that since we last talked, they're less understated these days because they're very proud of the work that they're doing.
Well, that is true, and we're certainly proud of them too. So as a scientist, do you have any parting words for us as humans and Mainers to make it through this time?
It's one of hope. You know, we'll get through this. We will get through this. We'll get through this because I believe the progress. I mean, I watch it, I read it, I hear it, I talk to my colleagues who are in the midst of it. We're in the midst of it. It's going to get taken care of. I'm just absolutely confident of it. The problem is time. It's a matter of time. The second part of it is, look, you know, a lot of times people view scientists either as their saviors or as demons, you know, one of two, okay? We're neither, we're human beings. And so what I mean by that is whatever I tell you is to my best of my ability of what I know, okay? But the pandemic is a classic example of how we have to view science as a tool for society, tool for humanity, okay? We're not going to make decisions simply based on a mathematical equation. There are political, cultural, social considerations that completely negate the realities of an equation. And this is what democracies are all about. At the same time, please understand that we do make mistakes. And science is not perfect. And science is actually an iterative process until you've tested a hypothesis so thoroughly that it never gets negated if it's challenged in the right way. We're not there with COVID-19. We're still learning. And so we've got to be able to learn together and be really objective about it.
Mm-hmm. Well, I can't thank you enough for all the time that you've given us today. We're so thankful to have you and the Jackson Labs here in the state of Maine. And I guess my advice for everyone is to stay patient and stay the course, help each other, support local businesses where you can, and enjoy this upcoming beautiful long weekend in Maine. So we will see you next Friday with Mike Simons. And thank you again for joining us today. And thank you, Dr. Liu.
Great. Thank you so very much, Lisa.
Always a pleasure. Thank you.
Absolutely. Bye-bye.